And so let's continue our discussion on operations on functions with a new operation. This operation is called composition. There went my pencil lid. Composition of functions. Operations have little symbols to represent them. There's a little T to represent addition. We have a little dash to represent subtraction, a little X or dot to represent multiplication, a fraction bar to represent division. But by the time this operation was invented, they had to come up with a good symbol for it, and all the others were taken. They had to come up with a symbol for it. So here's the one they came up with. It's a pretty good one. F composed with G of X. Sort of looks like fog. It's a little O for f of g of x. That's defined to be, in terms of function notation, f of g of x. And the order in which the functions are written is significant. If it had said g composed with f of x, g is on the outside and f of x is on the inside. So the first function written with the little o is the outer function. The second function, that's the inner function. And this is just function notation. This is saying go to G, wherever you see a variable, plug in the function f of x. This is saying go to F, wherever you see the function, a variable, plug in the function g of x. So I have a problem I want us to look at. This is, oh, wait a minute. I'm going to blow this up some for y'all. There. Okay. And this is number 4 in your homework. They want us to find h composed with f of 5. So h composed with f of 5. Which function's the outer function? H is on the outside, and on the inside we have f of 5. You know how to find f of 5. That was in the function homework that we did last week. F of 5. What is f of 5 saying to do? You come up here to f, and wherever you see an x, you plug in 5. So far, you have a 4 times a 5 minus 1. There's my scratch work. What's f of 5 giving me? We plugged 5 into f, and what's that reducing to? 19, I agree. 20 minus 1 is 19. Now we want h of 19. What's that saying to do? I'll get us started. We go to the function h, and wherever you see a variable, you're going to plug in 19. So we come up here, where we see that variable, becomes a negative 19 plus 3. Plugging in negative 19, we get a negative 16 for our final answer. We plugged 5 into f. That gave us 19. We then plugged 19 into h. H of x was negative x plus 3. I blocked out that variable. Let me rewrite that. So we plugged f into 5. That gave us 19. We plugged 19 into h. That gave us negative 16. Any questions? Okay. Remember, functions can be defined using tables. Functions can be defined using tables. Here's one where we're using tables. They give us 2 tables. This is your number 5 in your homework, by the way. The longest part about this problem is I guess if you're copying down the tables, that's it, because this is a very short problem, provided you understand how function notation works. First thing I would do is I'd rewrite that composition using parentheses. We want to find f composed with a g of 14. That's f of g of 14. That means which function's on the outside? F is on the outside, and on the inside we have g of 14. What's g of 14? I remember having some problems in the function homework where we were evaluating functions using tables. So, what's g of 14? You go to the g table. 14, okay, you're right. 14 is assigned to 12. So g of 14 is 12. We still have that f on the outside. What's that saying to do? F of 12. Okay, you go to the f table. 12 is assigned to 7 for a final answer of 7. Any questions there? You go to the g table. 14 is assigned to 12. You then go to the f table. 12 is assigned to 7. No? No questions? Pretty painless. Let's see if I can find one that's a little bit more involved. A composition of two functions at a number is another number. That's what we've been seeing here in the last two problems. A composition at a number is another number. A composition at a variable is going to turn out to be another function. So we're going to be expecting a variable to appear in our final answer. So we have two functions. We have f of x equals 5x minus 4. This is number 7. This is number 7 in your homework. We have f of x equals 5x minus 4. We have g of x. They give us g of x, and that's 7 minus 2x. They want us to find f composed with g of x and then g composed with f of x. Start off f composed with g of x. Which function's on the outside? For f composed with g of x, which function's my outer function? F, okay. Y'all don't have to worry about recording. What y'all say doesn't, it doesn't pick it up. So if you don't want to be recorded, they can't hear what you say anyway. That's why if you even say the wrong answer, I just go on and pretend I say the right answer and keep going. They can't. They can tell someone says something, but they can't hear what you're saying. So if you answer even wrong answers, it can't pick it up. So what's on the inside? G of x. Well, we know what g of x is. G of x is that red function 7 minus 2x. F is on the outside. G of x, we know what that is. That's on the inside. So this now says, go to which function and plug in 7 minus 2x. Go to f, and wherever you see a variable, plug in 7 minus 2x. So we come here to f. Where that blue, the blue x is, we have 5. We're going to replace the blue x with the red 7 minus 2x. Is that all we have? Do we have something else that we have to write here? The minus 4, right. And we know how to simplify this. Distribute the 5 to give us a 35 minus 10x minus 4. And we can combine our like terms. 35 minus 34 is a 31 minus 10x. For my answer to the first part. Now they want us to find g composed with f. We're going to reverse the outer and inner functions. There. Now they want us to find g composed with f of x. So that means in this case, g is on the outside. What have we got on the inside? F of x, and we know what f of x is. F of x is that 5x minus 4. The state of Texas says y'all should be able to communicate mathematically. So, what is this g of 5x minus 4 saying? It's saying go to the function g, and wherever you see a variable, plug in. So we're going to come up here to the function g, where we see the variable, we're going to plug in 5x minus 4. So we have a 7 minus 2, replace that x with 5x minus 4, and I distribute through that negative 2. That'll give me a 7 minus 10x plus 8. Don't make the mistake of subtracting this 2 from the 7. Remember your order of operations. You multiply before you subtract. So distribute the negative 2 and then combine to give us a final answer of, I guess I'll put my constant term first. 7 plus 8, I'll write that as a 15 minus 10x. Any questions there?